Hey, Mr. Herdman again. The beard is back. Anyways, we're going to go over dissolving ionic solutes and polar covalent solvents here. So, first blank here is disassociation. Disassociation. Process of a compound splitting into its ions when it's dissolved into a polar solvent. Acids, bases, and ionic compounds all undergo dissociation. Okay, so in dissociation here, the ion charge bond is between the The bond between the ionic bonds is broken. And the intermolecular forces of the ions make a positive and a negative. And they correspond with the polar ends of a covalent substance. While polar covalent compounds may be soluble in water, they will not dissociate. Because these are covalent compounds. Covalent compounds don't dissociate unless it's an acid. And even then, I consider the acids ionic. Okay. They can dissolve, but they do not dissociate into ions. So, we will illustrate the dissolving process for ionic solutes in covalent solvents like water. You need to show the positive and negative ends separated. Okay, and the water molecules will position themselves around the water so that they will attract. So down here, we're going to look at an example of NaCl, which is sodium chloride. And we know sodium chloride is ionic because it has a metal and a nonmetal. So when we put this into water here, the NaCl will dissociate into Na ions and Cl minus ions, which are both aqueous. Okay, and that's a little off the screen. Get back on the screen, Mr. Herdman. Okay, so what happens here, these are our water molecules. Remember, water has an oxygen and two hydrogens. Remember that the the hydrogens are partial positive and the oxygens are partial, or partially, I guess in Herdman English, negative. So you see here there's a chlorine right here. This is negative. Notice that the negative is attracted to the positives of the hydrogen. You don't see any negative oxygens next to your water at all, do you? By Jove, you don't. Okay? And sodium is positive. And you notice here that the oxygens are all pointing towards the sodium. That's because negative attracts positive. We all learned this from Paul Abdul, because opposites attract. Hopefully we know who Paul Abdul is. If not, oh well, it's okay. But anyways, the partial negative charges of the oxygens are attracted to the positive charges of the sodium. Okay? Let's go on to page 6. Okay, for KBr, okay, and I'm going to show you how to write dissociation reactions in the next video. So don't worry if you don't understand this right now, just watch the next video. So here we go. We got KBr, which is aqueous. This is going to dissociate into K ions and Br minus ions. Okay. So when we put this into water, and all ions are aqueous, you won't see me write the AQ underneath the ions, but I understand that they're all aqueous, so you don't have to do that. So we're going to have a K ion, and we're going to have our Br ion. Okay? have our water molecules, correct? Remember, our hydrogens are partial positive and our oxygens are partial negative. So since K is partial positive here, the oxygens are all going to be arranged around the potassium, like this. And I should probably put some dots on my oxygens. Notice that there are no hydrogens on my potassium, because that would be positive and positive, and that don't work. Now, let's go over. I'm doing multiple things at once. You just don't realize it. Bromine here is negative, so we're going to have our positive hydrogens attracted to our bromine. Notice that the oxygens are nowhere close to my bromine, because that would be negative, negative. Okay, and that's probably some of the ugliest waters I've ever drawn, but it's all good. Okay, so in summary here, to summarize, or if you ever watch the old World of Chemistry videos, to review. I'll have to show you one of those one day. They're pretty funny. They're like videos from like 1980 of chemistry. The guy has an awesome beard, much like me. Covalent. Likes, dissolve, likes. Okay. Will not dissolve into ions. We will break some intermolecular forces and form some intermolecular forces. Some new intermolecular forces. Nonpolar and ionic, they are insoluble. In Mr. Harridom's world, he likes to use the words ionic is extreme polar, and extreme polar is not going to mix with nonpolar. That don't work. Polar and ionic. Okay. We are going to check the solubility chart. Okay. Ionic compounds will dissociate into ions when dissolved. You're going to break the ionic bond and form ion dipole attractions. Okay, I think that's enough for today's video. You guys are champions. The legend is out.